In this lesson, we're starting to look at another kind of number called imaginary numbers. And the imaginary numbers kind of start with the imaginary unit I, which is the square root of -1. So if I'm trying to solve an equation like this, no problem. I can take the square root of a positive number. We've been doing it for years. So I'd take the square root of both sides and get x equals, and this might be new to you, it's positive or -4. Anytime you're taking an even root of an equation in order to solve for a variable, you've got to have this plus or minus sign, because think about it. 4 squared is 4 times 4, that's 16, but also -4 squared is -4 times -4, which is also positive 16. In part B, when I'm taking this square root, I have square root of x squared equals the square root of -9. And so again, I'm going to have a plus or minus, but additionally, because I'm taking the square root of a negative number, I'm going to have an I. So x equals positive or negative 3i. And then here you have some vocabulary about complex numbers. And next, we're adding and subtracting complex numbers, which is just as easy as combining like terms. So 4 plus -11 is -7, and -7i plus 9i is 2i. If I have 6 plus 8i minus 2 minus 5i, I would advise starting with getting rid of the parentheses. So getting rid of the first parentheses doesn't change anything. I've got 6 plus 8i, but then think of this minus sign on the outside as a -1 that I need to distribute. So this is now -2 and then plus 5i. And then again, you're just combining like terms, and you have 4 plus 13i. Next, we're using distributive property with complex numbers. Again, the mechanics are no different. What you are going to do differently is when you have an I squared, since we know that I squared is -1, when we get an I squared, we'll replace it with -1. So get my handy dandy calculator. -2.5 times 8 is -20. So that's -20i plus, because negative times negative is positive, 9 times 2.5, 22.5i squared. And then, as I said previously, this I squared becomes a -1. So now I have -22.5 minus 20i. Here, it's kind of like you may have learned FOIL in Algebra 1, first, outer, inner, last, exact same process here. So this gives us 9 plus 6i minus 6i, and then minus 4i squared. So notice that the 6i minus 6i, they're going to cancel each other out, leaving me with 9 plus 4, because remember, I squared is -1, and so that's 13. Notice the relationship between these two terms being multiplied together. This is 3 minus 2i, this is 3 plus 2i. And on the next page, you'll see that they are referred to as complex conjugates. And when we multiply complex conjugates together, as we saw their product is a real number. So we use that when we're simplifying a quotient with complex numbers. Okay, so this 10i over 2 minus I, I'm going to rewrite that just so that it makes a little bit more sense. Because this I can put over 1. And then, in order to simplify this, I'm going to multiply by the conjugate. But whatever I do to the bottom, I must also do to the top. So I'm distributing in my numerator. That gives me 20i plus 10i squared over 4 minus I squared. Because again, remember these middle terms, that's going to be a negative 2i and a positive 2i. They're going to cancel each other out. So now this I squared is negative 1 times 10 is negative 10 plus 20i over 5, because this is going to be a negative 1. So 4 minus negative 1 becomes positive 5. And I can reduce this fraction. And when I do, I get negative 2 plus 4i. In Algebra 1, you should have learned that you can factor a difference of squares. Here, we are factoring a sum of squares by using complex numbers. So this would factor as x minus y times I times x plus y times I. And remember, you can always double check your factoring by multiplying it out. X times x is x squared, x times yi, and then negative x times yi, they're going to cancel each other out. And then these two things multiplied together will give me negative yi squared, which would become positive y squared. In the next expression, I don't have a sum of squares yet, but when I factor the 3 out, because notice that both of these terms are divisible by 3, I have 4x squared plus 1. So now I have 3 times 2x plus I times 2x minus I. And then finally, solving this equation using factoring, we just saw in the previous example that we can factor this as x plus 2i times x minus 2i, and that equals 0. And using the zero product property, remember, if I have two things multiplying together to equal 0, that means one of them must be 0. So x plus 2i equals 0, or x minus 2i equals 0. So x is negative 2i or positive 2i. Remember, we can also rewrite this as plus or minus 2i.